So now we are starting to get into this idea of the algebraic dealing with limits. So dealing with limits algebraically. So here we've been given this expression, and if I plug in my 0, so when I evaluate my limit, I plug in 0, so I get e to the 0 minus 1 over e to the 0 minus 1, and I end up with 0 divided by 0. Now, 0 divided by 0, I can't evaluate because it can actually equal anything depending on how I get there. So this is a problem, the 0 divided by 0. Really the issue is if I can somehow get rid of the divide by 0, I can algebraically evaluate this limit. Okay, so that's really the process of how we algebraically deal with limits. We try to get rid of the divide by 0 and then plug in our number. So because this is new to us, we should really graph this. Okay, we should put this in our graphing tool and see what this graph looks like. In fact, for all limit problems, to get the answer, okay, there's often not an answer key, so to get the actual answer for the limit, we would just graph and see what happens. Okay, see what's happening at 0. So if I put this into my graphing tool, what ends up happening is I get this graph that looks like this. Okay, so it actually has a horizontal asymptote at 1, and it's crossing that point, and if we take a close look at that point, it's actually equal to 2. So how do we algebraically get that value of 2, of y equals 2? That's actually positive 2. So how do we get a value of y equals positive 2? Well, to do that, what we want to do is we want to get rid of the divide by 0 in the expression. So to do that, if I take a look at this expression, really this is e to the x squared minus 1 over e to the x minus 1. Well, the numerator is a difference of squares. So then I can rewrite this. The limit as x approaches 0, this really is e to the x plus 1, e to the x minus 1. And that's all over e to the x minus 1. Well, that e to the x minus 1 is what was generating the divide by 0. If I can get rid of that divide by 0, I can now evaluate this limit. So the process is essentially, we want to try to algebraically get rid of the divide by 0 and then plug in my limit. So if I plug in my limit, I get e to the 0 plus 1, and then that's the only expression that's left. So I end up with 0, e to the 0 is 1 plus 1, so I get the value of 2. And notice that algebraically now, I have generated the value of the limit when I did it by graph. So the process essentially, and we'll get more into this later, but algebraically we want to somehow algebraically get rid of that divide by 0 and then evaluate the limit at that point. In this case, it was at x equals 0.